If you're watching the recording of this session on YouTube, I invite you to join me next time live. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial on quantreasoning.com. So, the key to solving a question like this is to really take the time to rephrase what they are asking. So the work should be done not in the statements, but in the question stem. That's very often the case in data sufficiency. A lot of people go to the statements too soon before they've really thought deeply about what the question is asking. So let's see what thinking we can do on this question. In other words, under what circumstances would the absolute value of x minus y be greater than the absolute value of x minus the absolute value of y? That's what we need to think about. Under what circumstances would the answer be yes, versus, on the other hand, under what circumstances would it be no? If we can figure that out, then we can rephrase the question to something a lot more digestible. And then evaluating the statements should be pretty quick and easy. So, if I have 2 minutes for this question, I'm perfectly comfortable spending 1 minute and 45 at the question, because I'm confident that 15 seconds remaining for the statements is going to be more than enough. And if it ends up not being more than enough, if I end up getting to the statements and it's still going to be a lot of work, that means the question was too hard for me and I should guess and move on. But I have to be comfortable taking the time to really think deeply about the question. Under what circumstances would it be a yes? And under what circumstances would it be a no? Do you guys have a good way of thinking about the absolute value of x minus y? In other words, how do you digest that? What does it really mean, the absolute value of something minus something? Would the absolute value of x minus y ever be negative? Would the absolute value of anything ever be negative? Now, an absolute value can be 0. What would cause this particular absolute value to be 0? Exactly. If x and y are in exactly the same spot, then the absolute value of x minus y would be 0. But as long as they're in different spots on the number line, the absolute value of x minus y will be positive, and it will represent, exactly like JD said, the distance between x and y. It's just going to give you how far apart they are on the number line. And that's worth memorizing, but that's a rule you can take to the bank. The absolute value of a difference represents the distance between them on the number line. That's always true. And so imagine 2 numbers on the number line. One is on the left, one is on the right. They're 5 units apart. Are you imagining it?
If both are positive.
Forget the sign. It doesn't matter where they are. They're somewhere on the number line.
Okay.
They're 5 apart from each other. Take the left one and then subtract from it the right one. Are you able to see that that would yield negative 5? So that's what this is saying. We're saying, if you look at my number line here, you've got x, you've got y. I don't know where 0 is on this number line because it's irrelevant. I know the distance between x and y is 5. I know x is on the left and y is on the right. I can infer from that x minus y is negative 5. And I can also infer that y minus x is positive 5. These are 2 inferences that I can make directly from the drawing of the number line. I want to show you one more thing. So for you, the previous thing you wrote in the chat, you wrote absolute value of x is 5. And you were kind of looking at how to digest that. But one way to think about the absolute value of x, you could rewrite it as the absolute value of x minus 0. Do you all agree with that? This is the correct rephrasing. So going back to our insight about the absolute value of a difference, how would we interpret this? The absolute value of x minus 0 is 5. That's telling us that the distance between x and 0 is 5. 0 and x are 5 away from each other. I mean, it's just like we just did absolute value of x minus y is 5, right? That was the second example. So if instead of y we have 0, it's just saying that they're 5 apart. X and 0 are 5 apart. Right? So here there are also two scenarios, and these are the two scenarios. Like, I don't know which one is on the left and which one is on the right, but they're 5 apart. So the same would work for absolute value of x minus 0. You would say, look, I don't know which one is on the left and which one is on the right, but what I do know is that they're exactly 5 units away from each other. And that translates into x is either 5 or negative 5. Or if it's to the left of 0, then you just know that it's negative 5, because it's 5 units away. Yeah, if it's to the left of 0, it'll be negative. And if it's to the right of 0, it'll be positive. What comes to my mind, if you tell me the absolute value of x minus y is 5, I'm thinking they're 5 away from each other on the number line. The word negative never comes into my mind. Because it's not about negative, it's just about how far away they are from each other on the number line.
And do you know if x to the left of y or y to the left of
I have no idea. That's really what the absolute value is doing, is it's hiding the order of the unknowns on the number line. The relative order of the unknowns on the number line is hidden by the absolute value. Because think about it, if we were told x minus y is 5, how would we translate that onto a number line? We know exactly what to do. We would say, here's y, here's x. I know x is to the right of y, and I know that exactly the distance between them is 5. I don't know where on the number line they are, right? They could be in the negative millions, they could be somewhere close to 0, or they could be in the positive millions. I have no way to orient myself on the number line, but what I do know is two things. I know how far apart they are from each other, and I know their relative order. The minute you slap an absolute value onto that difference, what you've done is you've hidden the relative order of x and y. You're still showing me how far away from each other they are on the number line, but you've hidden their relative order. That's right. Yeah, the absolute value is the thing that gives us this double-sided arrow. This came from the absolute value. Without the absolute value, you wouldn't have that double-sided arrow. But I think it's important to emphasize again that in both cases, whether we have an absolute value or not, we have no idea where we are on the number line. Are we in the negative millions? Are we somewhere close to 0? Are we in the positive millions? Just no way of knowing. So I think that's important to emphasize. And that's also why the word negative never crossed my mind. Because negative would imply something about which side of 0 we're on. Specifically the left side. But I have no idea where I am on the number line, and I'm okay with that. So there's a lot that we don't know here, but what we do know, the only thing we know, is that the distance between x and y is 5.
That's the only thing you know.
That's the only thing we know. And just to one more time take this back to the absolute value of x, and let's say that was given as 7, and then thinking of it as x minus 0 in absolute value is 7, because that's the same thing. Okay, so what does that tell me? Same kind of deal, right? I don't know which is x and which is 0, but I do know that the distance between them is 7. So x is 7 units away from 0, but I don't know what the relative order is. And then from there, you could infer that x is either 7 or negative 7. Because if something is 7 units away from 0, then one thing you can say for sure is it's either 7 or negative 7. Those are the only options when you're 7 units away from 0. And I find this to be a much, much better way to think about absolute values in general, and especially for the GMAT. Like, any algebraic inferences can be secondary to the diagram, to the number line. First of all, draw the number line and think about how far apart things are based on the absolute value. Then if you need to, you can make algebraic inferences from that. So now that we understand all of that, I think we're ready to go back to the question stem. I think we have a much better understanding now of what the left-hand side of the question stem represents. Right? It's talking about how far away from each other x and y are. And the question wants to know under what circumstances would that distance between x and y be greater then what? How would you digest the right-hand side of the inequality? No, I think you're doing some good thinking there, but I also think there's some room for improvement. Specifically, you're breaking it down into what if they're both positive, what if they're both negative, what if one is positive and the other is negative, what if it's vice versa. That's a lot of work. And I'm thinking, since it's talking about absolute value of x and absolute value of y, maybe instead of thinking about all these different scenarios, which you could, it is possible to solve the question that way, but I think the more efficient way to talk about it is distances from zero. In other words, just ask yourself, so what if x is farther away from zero than y is? Without committing to positives versus negatives. What if y is farther away from zero than x is? Because the absolute value of x is describing x's distance from zero. And the absolute value of y is describing y's distance from zero. So I think the more efficient way to think about the right-hand side is, what if x is farther away from zero? And just to draw that on a number line, what would that look like? If x is farther away, here's 0. And let's imagine that y is either here or here, and then x is either here or here. This is the scenario, and you can put the double-sided arrow there and the double-sided arrow there. There's really 4 different scenarios included here. One where they're both negative, one where they're both positive, one where y is negative and x is positive, and one that's the other way around. But what they all have in common is that x is farther away from 0 than y is. Exactly right. Exactly right. The right-hand side of the question stem is going to be positive if x is farther away from 0 than y is. Conversely, if x is closer to 0 than y is, the right-hand side of the inequality would be negative. Now, if it is negative, then I think we have an automatic yes. Right? Is the left-hand side greater than the right-hand side? Well, we know the left-hand side is never negative, because it's a distance between two things. So if the right-hand side is negative, that's a yes. If y is farther from 0 than x is, that's a yes. Is there a way to also get a yes if x is farther away from 0 than y is? Is there still a way to get a yes? And what I want you to think about for that, what kinds of values would I take for x and y so that the distance between them is greater than the difference between one of their distance from 0 and the other one's distance from 0? Would having x and y on opposite sides of 0 be a way to kind of maximize the distance between them versus if they were both on the same side of 0? Like for a given absolute value of x and a given absolute value of y, just as an example to make it less abstract, if I tell you absolute value of x is 3 and absolute value of y is 5, would putting them on opposite sides of 0 kind of maximize the possible distance between them? Yeah, they'd be 8 away from each other. And by the way, JD, I don't know which is positive and which is negative, right? All I said was x and y are on opposite sides, and I gave you the absolute values, and you were able to infer the distance between them without actually knowing their relative order, without knowing which one is negative and which one is positive. Isn't that cool? You were able to infer that they're going to be 8 away from each other just from knowing their absolute values and knowing that they're on opposite sides of 0. The difference between -3 and 5 is the same as between -5 and 3. In both cases, they're 8 away from each other. But remember, for the case in which y is farther from 0 than x is, we don't even need to think about that anymore. We already established that as long as y is farther from 0 than x, that's an automatic yes. So you actually only need to think about the case where x is farther away from 0 than y. I want to try something else with you all. I want you to think back to the left-hand side of the question stem. And I want you to think about the case in which x and y are on opposite sides of 0. Because we all agreed that that was kind of a way to maximize that value. Maximize the distance between these two numbers as if you put them on opposite sides of 0. And what I want you to do, this is a pretty tough question that I'm asking you to think about now, is given that x and y are on opposite sides of 0, how do you rewrite this expression using this and this. So there's a missing, visualize some kind of missing operation in there. Are you able to do this? Again, given that x and y are on opposite sides of 0, you must visualize it on a number line. That's how you get better. So we are saying if x and y are on opposite sides, and I don't know which is which, but that's okay. This is this. It's the distance between x and 0. This is this distance between y and 0. And finally, this is this distance between x and y. And you can see now that that light green distance is the sum of the dark green and the purple. Okay, so let's do this. So here we're going to have in pink the absolute value of x.
Yeah.
We're going to have in purple the absolute value of y. We're going to have in dark green the absolute value of x minus y, or y minus x. That's the same. You realize that that's the same thing, right? Absolute value of x minus y is the same thing as absolute value of y minus x, because in both cases it's giving you how far away from each other they are in the number line. So we'll use gray for this, right? So we want pink minus purple.
Right.
So what that will give you is this, but with a negative in front of it. Yeah. So whatever that gray or silver, let's call it a silver color, whatever that silver distance is, with a negative sign in front of it.
And that gray is never equal to the green.
Well, no, because the green in this case, I don't know about never, but in this scenario that we drew with 0 followed by x followed by y on the number line, the dark green is a positive number, and the silver would be a negative number. So they would actually equal one another in absolute value. They're equidistant from 0, but on opposite sides of 0. The green is positive and the silver is negative in this case. So back to the original question, which was all the way back here. In the scenario in which x and y are on opposite sides of 0, this gets maximized and ends up being equal to the absolute value of x plus the absolute value of y. That was the insight we had here. And what I'm thinking is that when comparing absolute value of x plus absolute value of y to the right-hand side here, can we tell which will be bigger? Absolute value of x plus absolute value of y will always be bigger than absolute value of x minus absolute value of y. There's only one case in which they would be equal. This compared to this, the left side will be greater except for if y is 0. If y is 0, they would be equal. The thinking that I'm doing here is that this guy is the same on both sides, and this other guy is never negative. It's either positive or 0. If it's positive, then the left side is bigger, and if it's 0, then they're equal. That's right. It's subtracting something positive from a given number, whatever our absolute value of x is. We already wrote down one conclusion, which is if y is farther from 0 than x is, then that's an automatic yes. What if it's the other way around? What if x is farther away from 0 than y is? You'd still get a yes if what? I'll give you a little reminder here. We had a pretty significant insight with regards to the left-hand side of the question when I asked, how would you maximize the distance between x and y for given distances from 0 of x and y? If x and y are on opposite sides of 0, that's the other way to get an automatic yes. And I think the big takeaway from all of this analysis that we're doing here, because you're obviously not going to go through all of that in the middle of a test, but the big takeaway is that when you're dealing with absolute values, it doesn't really make sense to split into different scenarios of positives and negatives. Instead, you want to split into different scenarios of distances from zero. Like who's farther away from zero than whom? And also which side of zero we're talking about. But not so much, what if they're both positive? What if they're both negative? What if this is positive and the other is negative, and vice versa? It's an inefficient way of evaluating absolute values. What I want you to do now, given everything that we've discovered today, is I want you to make an educated guess without using pen and paper. And I'll remind you how we rephrase the statements. From the very, very beginning, how did I digest statement one? I said, y sits to the left of x on the number line. Okay, so statement one gives us the relative order of x and y on the number line. What about statement two? We digested it as x and y are on opposite sides of zero on this number line. So I want you to think about what this question is really asking in the context of all of the discovery that we've done today. And I want you to make an educated guess. Think about the kind of information that each of these statements is giving us. Think about that number line. Think about what it's telling us. Think about our ability to orient ourselves on the number line. That's not an educated guess. That's a beautiful inference. You've come so far just in the last half hour. Kudos to you. That was amazing. What JD is saying is, hey, statement 2 tells us that x and y are on opposite sides of 0 in the number line. And what that means for this left-hand side is that's going to be maximized because when you put them on opposite sides of 0, the distance between them is getting maximized. Whereas here, you're just taking one of those guys' distance from 0 and then taking away from that. Instead of adding to it, you're taking away from it. That is a beautiful inference. So given that they're on opposite sides of 0, the left-hand side automatically is going to be bigger than the right-hand side. And I love the words you used there, JD. In the right-hand side, we're chipping away from, whereas on the left-hand side, we're adding to. And it goes back to what we did earlier, which was we said in the scenario of x and y on opposite sides of 0, this is equal to this. And that's always going to be bigger than this, as long as x and y are on opposite sides of 0. And that wasn't an educated guess, that was an inference. That was beautiful. So that right there allows us to eliminate A, C, and E. Right? It's already a 50-50 shot, and you didn't even need pen and paper, JD. All you needed was to have spent an hour at the Ask Me Anything event. No need for pen and paper. Immediate elimination of 3 answer choices. You realize now it's unnecessary, right? No need to work so hard. And I honestly think this is what the question is designed to test, right? They designed this question to benefit people who really know how to think about the absolute value of a difference. It's how far apart they are in a number line. And people who know how to think about this, it's just saying they're on opposite sides of the number line. Then they realize that would maximize how far away from each other they are. And as you said, here we have something chipping away from something. I really think that's what it's designed to test. What do you all think about statement 1? Again, think about the kind of information we're given in statement 1 in the context of what they're asking. What would you guess, as an educated guess, would you think that statement 1 is going to be sufficient on its own or not, and why or why not? So I want to give you two radically different approaches to evaluating statement 1. And I think they're equally good. For the first approach, I'm going to use the fact that we've already established that statement 2 is sufficient on its own. So this only works if you started with statement 2. The other approach I'll give you works regardless, but we'll start with this one. So if you started with statement 2 and decided that it is sufficient on its own, and you saw that it gave a definitive yes, right? It answered the question with a definitive yes. You remember that? If x and y are on opposite sides of 0, then we get a definitive yes. The absolute value of x minus y is always going to be greater than the difference of the absolute values. What that means is that statement 1 must at least allow for the possibility of a yes. I don't even have to show that it can be a yes. I'm using the GMAT's own rules against it. Right? We know that the statements are not allowed to lie. They can't contradict. So if you ever get one statement gives a definitive yes and the other statement gives a definitive no, you've made a mistake. You have made a mistake. It is not possible to have each statement is sufficient on its own and they led to different answers. That's not possible. So using that logic, I can say, thanks to the fact that statement 2 was sufficient on its own and gave a definitive yes, statement 1 has to at least allow for that possibility. So if I'm trying to prove insufficiency for statement 1, I don't have to show that it can lead to a yes. I already know it can lead to a yes because statement 2 was a definitive yes. All I have to show is that statement 1 can lead to a no. And as Padmanav said, if you just take the scenario of them both being positive, that would lead to a no. Because the two sides of the inequality that we are being asked about are equal if x and y are both positive and x is to the right of y. So that's one way to prove insufficiency in a relatively easy way. You just take the easiest case you can think of where they're both positive. You get a no. You already know you can get a yes because of the GMAT's rules, and therefore the answer is B. So that's one way to finish this out with very minimal work. Here's the second approach. And this is what I would do. With statement 1, I would draw a number line that shows the y is to the left of x. But because of the way this question looks, look at the way this question looks. In the context of that question, what do you think I'm really curious about for this purple number line? What would I want to be able to place? There's one very specific value that I really want to be able to place on this purple number line in the context of that question. Tobias, you look like you have an answer.
0.
Exactly. In the context of an absolute values question, the number that I would really love to be able to place here is 0. So the question I would ask myself is, where does 0 go on this number line? Is 0 here? Is 0 here? Is 0 here? Where is 0? Would keep asking that question. Where is 0 on this number line? Statement 1 fails to give us any way to place 0 relative to x and y. You see how that's very different from statement 2? Statement 2 places 0 in between x and y. So when we plot x and y on the number line, we can tell where 0 belongs on that number line. Statement 1 fails to do that for us. And I would feel confident enough at that point to pick B. Now, is that a 100% certainty kind of choice, or is it an educated guess? I would say it's somewhere in between. It's like a very, very, very educated guess. I know that 0 is crucially important. The positioning of 0 relative to x and y is going to have critical importance in the context of a question like this with absolute values. Because absolute value is all about the distance from 0. I should specify, specifically it's the right-hand side of the question that makes me care so much about the position of 0. The left-hand side actually doesn't care where 0 is. If we're just looking at the left-hand side on its own, who cares where 0 is? It's just describing the distance between x and y. 0 is not interesting at all for the left-hand side, but for the right-hand side, it's all about 0. Because, here, let me rewrite the right-hand side for you, so to make it clearer. Another way to write the right-hand side is like this. It's talking about x's distance from 0 minus y's distance from 0. So if I have no clue where 0 is on this number line, how could I possibly answer that? So let's evaluate This question now. Statement 1 would still not be sufficient on its own, because it doesn't give us anything about the positioning of 0. Would statement 2 be sufficient on its own? On its own, without even knowing which is bigger, x or y. See, if y is farther away from 0 than x is, they would be equal. Yes, the correct answer here is C, with these statements. Yeah, that's right. And I think the other big takeaway here is if you're talking about the absolute value of a difference, then a way to maximize that value is to put them on opposite sides of 0. And what I mean by maximize is, for given distances from 0 of each, you'd maximize the absolute value of the difference by putting them on opposite sides of 0. I'll say that sentence again, because that was a mouthful. If there are given specified absolute values of each unknown, and you want to maximize the absolute value of their difference, you'll want to put them on opposite sides of 0. The way I think of a plus b in absolute value is I think of it as a minus negative b. And then it's again a distance of two things. Because an absolute value of a sum is not easy to digest on a number line, so I just turn it into a difference. Any sum can be rewritten as a difference. So instead of a plus b, I call it a minus negative b, and then I plot negative b and a on the number line. And be careful, just because it's called negative b doesn't mean it's negative. I don't know where it is on the number line. Let me write that out for you. That was a good question, JD. So if they're talking about this on the GMAT, I rewrite it as this, and I draw a number line, and I say, I don't know which is a and which is negative b. So there's a double-sided arrow there. But the value of this absolute value is captured by this distance between a and negative b. And again, I emphasize, I don't know which one is a and which one is negative b, but the distance between them is going to be that, which is the same thing as that. Not necessarily, because I don't know anything about a and b, right? I mean, b could be minus 5 and a could be 3. So then negative b is positive 5. In other words, 0 could still very well be here, 0 could be here, 0 could be here, 0 could be anywhere. I have no idea where 0 is. Remember what I said. Just because it's called negative b doesn't mean it's negative. It's just a name. For all I know, a is negative and b is positive, and negative b is negative, or negative b, I mean, it could be anything. It's just a name. Negative b is just a name. I don't know what b is, and therefore I don't know what negative b is. No, I mean, if the GMAT is giving me something like that, absolute value of a plus b, I don't know anything about a and b. But I still want to have some way to capture the information. Like if they told me, hey, Avi, absolute value of a plus b is 8. So what do? I draw a number line. I say, I don't know where is a and where is negative b. But what I do know, and so let's put a double-sided arrow there, but I do know that the distance between them is 8. There's 8 units between these two values on the number line. Where is 0 on this number line? No idea. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.